Okay, so today what I want to go over is special right triangles. This will show up a lot on the SAT, and what we need to be aware of is the two formulas, or rather the two pictures for special right triangles. So there's two different ones. There's the 30, 60, 90, and there is the 45, 45, 90. So they're both going to have a 90-degree angle, but there's two different triangles that have this. Now there can be other right triangles, right? You can have a right triangle that has a 90-degree angle, but then let's say it looks like this, right? Now this may look like one of the ones up there, but if they don't tell us that one of these is 30 degrees or 45 degrees, then we don't know. For example, if this was 30 degrees, then we know it's a 30, 60, 90. And if it was 45 degrees, even though it doesn't look like the 45-degree triangle, this would be the same kind of triangle. So if we know that it has a right angle and either one of these 30, 60, or 45, it's a special right triangle. That's the first thing we want to be able to do is identify what kind of triangle we're working with. If it's not a special right triangle, we'll talk about that in a different video. So let's look at a problem. This tells us that we have a right triangle shown, DF equals EF, which equals 3. So this is a special right triangle because we have 90 degrees in one of the corners, and it fits the pattern here, where you have two of the sides are the same. So this is sometimes also known as an isosceles right triangle. This is the 45, 45, 90. So let's redraw our picture, and I'm going to label it just like they showed us here. We have 3, 3, and then 90 degrees here. And we want to find side X. So this is really all we need. We don't need to know the letters. We just want to know what X equals. So in our case, if we look at our special right triangle, we have it up here. Let me redraw it again. Basically, the reason we can use these is because they're similar. So this is 45 degrees, and this is 45 degrees. This will be a 45 degrees, and this will be 45 degrees. And we know this because it fits the pattern that two of the sides are the same and there's a 90 degrees. So two of the sides are the same and there's a 90 degrees. In our special right triangle, we call this one S, S, and this is S root 2. So we can set up an equation, and maybe you can already see what X is going to be, but it's really helpful to set up an equation because in this picture, S is the same thing as 3, right? If we let S be 3, then we can find X because that's in the same spot where this is. So X must be S root 3, or another way to say it is X is 3. Oh, sorry, I made a mistake there. It's not S is X is not S root 3. X is S root 2, going with this pattern. So S root 2. So the X is 3 root 2. Okay, that's the answer. Is that clear? So we used our picture. We set up an equation for the side that we know about, solved it for the S value, and then plugged that into the X equation. Okay, we'll do another one with the 30, 60, 90 so you get the idea. So here's a different problem. In the right triangle shown, measure of angle A is 30 degrees. So this angle here is 30 degrees. And it's a right triangle. So we already know we're in a 30, 60, 90. Even though they didn't mention the 60 degrees, we know that this must be 60 degrees because it's a right triangle. And again, the reason we know this, if you're confused on how we know that, in any triangle, there's three angles, A plus B plus C, and they must all add up to 180 degrees. If we say that one of the angles is 90 degrees, then we can subtract that from both sides of the equation, and we get A plus B equals 90 degrees. Right, so let me draw the triangle I'm talking about. if we say that this is C and it's a right angle, then we just have A plus B must be 90 because you take away the 90 from the 180. And if we are told about one of these two angles, if we know that A is 30, that means B must be 60 because 30 plus 60 is 90. And if we know that A is 45, that means that B must be also 45 because 45 plus 45 is 90. This is why we know we're in a 30, 60, 90 when we only know that we're in a right triangle and we know one of the angles. Okay, so that's another way to think about identifying these things. Okay, let's keep going though with this problem. If we know that this is 30, we want to find AC. So they said AC is X here. So let's redraw our triangle. You don't have to do this step, but I think it's really helpful is to redraw the triangle with it in the same way that your picture is set up. So this is 30 degrees, which means that this side is in between if this is the 60 degrees. So we know that the side that has the 60 and the 30 has the 12 root 3. So this is the 12 root 3. That's how you can figure out which side goes to which value, right? The side that has the 30 and the 60 is the 12 root 3. So we kind of flip this picture around to match this picture. That way we can easily set up our problem. So this is X, and this is, we don't know this either. Let's call this Y. We don't need that, but I'm just going to give it a name since it's not known. So now we look at the place where the 12 root 3 is. This is in the same place as the 2x. So we can set up the equation that 2x must be 12 root 3. Right? We let these triangles equal each other, and we solve for x. So we get 6 root 3 by dividing by 2. I just divide both sides by 2. So now what we get is x is 6 root 3, and that's the thing we're looking for. So we're done. That's our answer, 6 root 3. Now, what if they had asked us not about this side, but this side? I'll do it in a different color. This side. What if this side? We called this side y. Oh, wait, careful. I made a mistake. Does anyone see it? We got x is 6 root 3, but I made a mistake because this is really important. They called this x, and so I wrote x here. But in our picture, there's also an x here. So this x is not the same as that x. Does that make sense? These x's are not the same. What we need to do is fix this. So what I'm going to do is I'm going to, instead of using x in the picture for the 30, 60, 90, I'm going to call it, I'm going to leave this one as x. But I'm going to call this S now. So I'm going to replace the X's in this picture with S, just like they did in this 45, 45, 90. I'm going to call it S so we don't get confused. Because really what we need to say here is that 2S is 12 root 3. And that means that S is 6 root 3. But on this picture, what does this side correspond to? In this, it's X, which is what they labeled here. But X is equal to S root 3. Which means that actually our answer is not 6 root 3. It's, we got to plug this in for the S value. So our answer for x is actually 6 root 3 times the square root of 3, right? This is S, and this is the root 3. So this is actually 6 times, well, the square root of 3 times the square root of 3 is just 3, right? When you have two square roots next to each other. So this is actually 18. Okay, careful. That one's tricky. The key was to notice that this x and this x in this picture were not the same. So if you're using x in the picture here, don't use x in the picture there. Use a different letter in this picture for the special right triangle. Very important. Okay. So let's do one more. I'm just going to make one up. So let's take away this problem. And let's redraw our pictures on our own. So from memory, let's draw our 30, 60, 90 triangles. So you need to have it memorized because you don't want to be looking at the test front page every time. So the way that I remember these is I use the unit circle 30, 60, 90. So the 30, 60, 90 in the unit circle is like this. The hypotenuse is always 1. This side's 1/2, and this side's √3/2. So if you haven't learned about the unit circle, you can just memorize the picture on the front of the SAT page. But this is another way to think about it. What we can do is we can turn this into that picture by multiplying everything by 2, and we get, I'm just going to draw roughly, we get 2, 1, and √3. And then we can multiply everything by x to get the picture that's in the front of the SAT. So this is how I remember the unit circle. I have these values memorized, and I just build this every single time, and then I go on to the problem. If you don't have the unit circle memorized, you can do it the other way, but this is a handy way to get those values and only memorize one thing. Okay, so now we have our picture for what the 30, 60, 90 is. Let's make up our own problem. Let's say that we have a triangle that we know about. I'm just going to make one up. Let's say that we have this triangle, and this angle is 30 degrees, and this is 90 degrees, right? So this must be 60 degrees. And let's say that this side is 5. What are the other sides? Well, we can set up our equation that 5 equals x. And then this side on the top, right, what's 2x? Well, 2x is 10. Right, so we first set this up by saying that this side matches this spot in that triangle. And then we just figured out that this other side we want to know is 2x, so we just multiply by 2, and we get 10. So this side's 10. And then the bottom side is x times √3. So x √3, well, x we got was 5. So 5 √3 must be what this side is. I hope this is starting to make sense. Okay, so let's do a 45, 45, 90, one more. So the 45, 45, 90 looks like this. And you can denote it this way. Because these sides are the same, you can do a little dash like that. So if I tell you that this side is 10, what are these two sides? They're going to have the same value, so we only have to solve it once. So let's draw our picture for our 45, 45, 90. If I do it from the unit circle, I know that this is √2/2. This is 1, and this is also √2/2. But let's fix that so that there's no fractions. We're going to multiply by 2x. So we get 2x is this side. And then this would be x √2. And this would be x √2. So this is the picture in the front of the SAT that we can use to match this picture. So what does the 10 correspond to in this picture over here? Is it the 2x or the x √2? It's the 2x because that's the hypotenuse of that triangle. 10 is equal to, almost wrote 10x there, 10 is equal to 2x. So in this case, x again is equal to 5, which means that the missing sides are x √2. Those are the missing sides, according to this picture, which means that they're also 10 √2. So that's what these sides are. Okay, so that's some stuff on the 30, 60, 90 triangles. Hopefully that makes sense. Careful with the letter X. If it shows up, pick a different letter for this, right? I could rewrite this, instead of using X's here, I could rewrite this with S. And then it's the same thing, I'm just using a different letter so that I don't get confused. Okay.